So just I will tell the things that is told already in that last backup class. So vector is a new kind of quantity in mass. What kind of quantity? Suppose if I tell you to travel from some location A to B, I have to travel 10 kilometers. So telling the distance that I have to cover or telling the amount that I have to travel to reach B from A is not enough. No, even I have to mention how we are supposed to travel that length of 10 kilometers. But many quantities, suppose if I ask you how to reach Kilpur from here, you can't tell me travel 10 kilometers. You must tell me how I must travel that 10 kilometer. No. So many quantities, like the way, suppose if I tell you that I have to travel some length in some direction. So suppose if I tell you travel 10 kilometers and maybe you travel in eastward direction in order to reach the point B from A. So how much I have to do or what amount we have to do, that is 10 kilometers. In what manner we have to do that thing, that is eastward. No. So many quantities are such where, so how much we have to do is called as magnitude, and in what manner we have to do that thing, we call it as direction. So there are many mathematical quantities or which are called vectors, for which just telling how much to be done is not enough. I have to tell the direction also. So there's a term comes in math called as necessary condition. So for something to be called as vector, it must have magnitude and direction. For example, if I talk about temperature, temperature thing has got no direction. So straight away, it is not a vector. Something having no direction is going to be guaranteed not going to be a vector. But something having direction, it can be a vector, it may be not going to be a vector. So sufficient condition that there's something called as, so sufficient condition for something to be a vector is it should follow vector algebra. So something having no direction, guaranteed not a vector. So necessary condition, yeah, yes, necessary condition is going to give us negative guarantee that if something not having direction is straight away not a vector. But something having direction not sufficient for it to become a vector, it should follow something we call it as vector algebra. That is what we are going to see in this chapter. I can give one example of electric current. Electric current has got both the things, magnitude like some amperes moving in some direction, and has direction. Still not a vector. The reason is it do not follows something that we call it as triangle law of vector addition. Okay. What is that triangle law of vector addition? Maybe we are going to see today. So if I have a quantity which is a vector, for that the symbol, suppose A is a vector quantity, then we are going to use a symbol, arrow over its head to tell that it is a vector quantity. So suppose if I have a vector A by which we travel 10 kilometers towards east, then I will say the magnitude of that vector is 10 kilometers. So the symbol for the magnitude is this one. That is something also called as modulus in mass. So we put these two bars around the vector A. That is the symbol for the magnitude. And direction it is having is eastward. So I hope these are like simple things you may be knowing it from before also. So how to represent a vector graphically? So vector A is of length 10 kilometers and it is in eastward direction. So what we do, we draw an arrow which is going to be pointing in the direction of that vector. So vector A is a vector whose magnitude is 10 kilometers given and direction given eastward. So we are going to draw an arrow which will be pointing towards east, and we will draw the arrow of what length? And who will draw the arrow of length 10 kilometers? No one, no. So we don't draw arrow of 10 kilometers. Maybe we take some scale. Like maybe we'll say 1 centimeter on ground is equal to 1 kilometer on paper. So we'll be drawing an arrow of 10 centimeters, but in our head we understand it is of 10 kilometers. So the magnitude of the arrow, see magnitude of the vector or the length of the arrow is going to represent the magnitude, no? Length of the arrow is going to represent magnitude. And the way the arrow is drawn or direction of arrow is going to be called as, is going to be in the direction of the vector. And this is called as tail of the arrow. This is called as head of the arrow. Have whatever drawn on the screen clear, no? I can take a new page. I'm going to share all of these things. So if you're not copying, that too is fine. You can take a new page. You can reply like this also. More respect, more heavy. Okay, I can take a new page. In case if you want me to come to this page, you tell me. So when I can say two vectors are equal, so whenever the word vector comes, it comes attached with two information. One is direction, other is magnitude. So if two vectors are equal, then they must be having equal direction and magnitude. Correct. Suppose if I am representing a vector using this arrow, maybe it is a vector whose length is 10 kilometers and it is in the direction which is eastward. And that vector name is A. Now I'm going to draw another arrow of same length as A in the same direction as A, but just I'm drawing it at some another location. See, this red arrow is of same length as the blue arrow, and this red arrow is in the same direction as the blue arrow. So his length is also 10 kilometers, and he is also pointing towards east. So tell me, if I tell you that we can use even this arrow, the red one, to represent A, is it correct or wrong? Correct only. So where I'm drawing the arrow, who cares about that? What is the thing which will be telling me the length of the vector, the length of the arrow, which is same? What will be telling me the direction of the vector, the direction which the arrow points same? It means the red arrow can be also used to represent A, and the blue arrow can be also used to represent A. So what I'm trying to tell here is, if I shift a vector parallel to itself, shifting or transporting a vector parallel to itself, the vector remains unchanged. I hope this point is clear. Okay. I can take a new page. Next thing is, you can given, see if I use the word velocity vector, I hope you get the meaning. No? Suppose if I have a particle moving with speed equals 10 meters per second towards east, then the velocity vector will be of magnitude equal to 10, and direction of that vector will be towards east. So tell me, if I write a statement, tell me correct or not. A car in India going towards, or a blue car in India is going towards east with 10 meters per second. And another black car in China going with 10 meters per second towards east. So the velocity vector of the blue car and the black car will be equal or not? So maybe different car, but who is talking about the car? We are talking about the velocity of the car, no? So the velocity vector of both the cars are equal vectors or not? I hope you got the point. Where you draw the vector, you don't worry about that. If length same, direction same, vector same. Okay. I'll take a new page. Maybe as I'll take a new page. Next thing is how to find the angle between two vectors. So the angle between two vectors, if I have to find, so here things are something where order is important. I'll tell you what it means. Suppose if I ask you find angle between vector A and B. Statement number 1. Statement number 2, if I ask you find angle between B and A. So both are not same thing, both are different thing. Angle between B and A. So here the place of A cannot be exchanged with the place of B, no? So here traveling not allowed. A can't travel to B place and B can't travel to A's place. So such case, whenever the order is important, we call it as non-commutative in nature. Okay. That is one point. Another point is, in order to find the angle between the vectors, vectors must be given to us this arrangement in which I'll draw it also. This arrangement, you see, in this arrangement, their tails are together. And tails are the like starting point of the vector or initial point of the vectors. So this arrangement has got a name. You don't have to know the name, just I'm telling you. Co-initial arrangement. If the vectors are having their heads together, we call that arrangement as, so heads are the terminating point. So they are having common terminating point, so we call it as coterminus. So vectors should be given to us in co-initial or coterminus arrangement. But every time it may not be like that. So what to do? If not given in co-initial or coterminus arrangement, then one of the vector is shifted parallel to itself to bring them in co-initial or coterminus arrangement. Okay, so maybe I'll take an example of finding the angle. So I can take a new page. Co-initial, you got the point tells together, you can say in layman's terms. And coterminus means heads together. Either they must be in this or that. Any of these two, whichever you like, you can bring them in that arrangement. Answer will be coming same. And one more thing I have to tell. In the way in which an analog clock moves, that is called as clockwise. And opposite to that is called as anti-clockwise, ACW. So sometimes angle could be in clockwise manner or could be in anti-clockwise manner, or it is also called as sense. So I must report not only the amount of the angle, we must tell what is the sense of the angle. So maybe who wants to use so much language and all clockwise, anti-clockwise. So we report answers sometime using symbols. So the sign convention that we have every time is this one. Anti-clockwise angles will be reported as positive. And clockwise angles will be reported as negative. Okay, I'll take a new page now. It's difficult to write now for you. You can come sit here, you can solve. For me, I can write anywhere. My surface is like hard. Without table, how you're writing? It's right here. And sit, please. You can take a new page, everyone. Now, suppose if I ask you, find the angle between A and B. So always check who is appearing first in the asking order. So vector A is appearing first in the asking order. And suppose this is how vector A and B are drawn. And they are already given to us in the co-initial arrangement. So this is our vector A and this is our vector B. Now if I ask you find angle between A and B, so maybe I'll give an example. Suppose your friend is like a sniper. Is that called when the one who fires a sniper gun? So suppose your friend is in some military operation and he's a sniper guy and he's sitting facing this side. And you're looking at them by using a drone sitting at your home only. And enemy is sitting somewhere here. And you have to tell your friend that you point the sniper rifle in the direction of the enemy. And it is given this black arrow or this black part angle is 60 degrees. So tell me, you will ask your friend to turn through how much angle? 300 degrees or 60 degrees? Tell me first. Got the question, no? So your the sniper rifle is pointed this way by your friend. An enemy is sitting somewhere here, and you have to tell him to point the rifle in the direction of the enemy. So you will ask him to turn the rifle through an angle of 60 degrees or 300 degrees. Obviously 60 degrees, no? Correct? And if you will tell 60 degrees, maybe, and he turns the rifle 60 degree this way, again headache, no? So I have to mention 60 degree which side. So left right will be confusing. So we'll say that 60 degree, the one I've drawn using this black color, is in what sense? Anti-clockwise or clockwise? Anti-clockwise, no? Correct. So what is the angle between two vectors will be? So first you check out which is coming first in the asking order A. So start from A, go towards B, through the smaller angle between them, and that is the angle between them. So you can think like this also maybe. So this is our vector A and this is our vector B. And if I ask you find angle between A and B, so you have two choices. One, you can turn the vector A around its tail to bring it at the place of B. For that, you can turn the arrow of A around its tail, like around here, through 60 degree that way, or you can turn it through 300 degree this way. So among these two, we are going to use the smaller one to report that has the angle between A and B. If I ask you find angle between B and A, then I will be doing the same thing, but starting from B. I hope this thing is clear to all of you. So now in the same question, if I ask you find angle between B and A, then you start from B and go towards A. You can go to A via this dotted path, or you can go to A via this solid path, but smaller one you will select. So the angle between, so from this figure you check out, angle between A and B, what answer I will report? It's going to be reported as 60 degree anti-clockwise. But maybe who will write so many language things, I'll say plus 60. In here, if I ask you what is the angle between B and A is, it is 60 only, but not in the same sense, no? Angle between B and A is 60 degree clockwise, and clockwise we write down as minus 60. I can write 60 degree clockwise, but I want to use symbols instead of language, then you can report answer like that also. So the angle between A and B is coming out to be 60 degrees. Then angle between B and A is coming out to be how much? Minus 60 degrees, no? So if angle between vector A and B, if I'm telling, is equal to theta, then the angle between B and A will be minus theta. I hope all of you have understood this thing. Okay, I can take a new page. So explaining this thing on board was like a lot more easier. But anyhow, you have understood, no? Because here I can't show you how I'm going to rotate A. I can show it through cursors, this cursor only. So I hope you got the meaning of the statement. If I have to find angle between A and B, we start from A and we go towards B. So I can go via this black path, or I can go via this red one. But among these two, which is smaller one, black one, so black one will be the answer of angle between A and B. Okay, clear to all of you. I will take a new page. If you want me to return back to this page, you tell me. Now, suppose if I tell you this is vector A, and this is vector B, and the angle that is between this angle is told to us that it is 120. So blue one is A and violet one is, I think violet color only, violet one is B. So can you find the angle between A and B? So right now from this figure you cannot, because I want the vectors to be in this kind of arrangement which is called as co-initial, or this kind of arrangement. If not given in such arrangements, we shift one of the vector parallel to itself to bring them in co-initial or coterminous. So see, what I'm going to do here is I'm going to draw an arrow to represent vector A. So that arrow should be of same length as the vector A and should be in same direction as vector A. So see, I'm drawing another arrow, this red one. So this red arrow is of same length as vector A. It is along same direction as vector A, but the tail of the red arrow is lying at the tail of the violet arrow, no? So now I can use this blue arrow also to represent A. I can use this red arrow also to represent A. So both are correct representation of A, but I want them to be in certain kind of arrangement to do something. So I will use the red arrow. Okay, so now you concentrate on the red arrow of A and the violet arrow of B. What kind of arrangement you see they are in? They are in an arrangement which is tails together or co-initial. Now, if I ask you find angle between A and B, so you forget that there's a blue arrow of A present. Just you concentrate on the red and the violet one. You start from A and you go towards B. So the angle between A and B will be this red one. And in this figure, you see the blue arrow of A and the red arrow of A are drawn on the same line. So this red one, this will be of what amount? 60 degrees. And what direction, or not direction, sense? It is anti-clockwise. Okay, suppose maybe you don't like tails together arrangement, maybe you want heads together, that too we can do. So I'm going to draw an arrow of same length as B, in same direction as B, just I'm drawing him here. Why? Because I want the head of the arrow of B to be at the same place as the head of the arrow of A. Now you concentrate on the blue arrow of A and the black arrow of B. Both are in the arrangement which is heads together, which is also a fine arrangement for us. Now what we do next, since I have to find angle between A and B. So A is appearing first. So we start from A and we go towards B. So when we start from A, yellow color not visible, no? Start from A and go towards B. This is going to be the angle between A and B. Now this is the angle. This is also the angle between A and B. What is that angle? Is 60 or not? Because this blue one and this red one are like opposite one, no? Vertically opposite, I think it is called as. So they are 60-60. So magnitude of the angle same. Sense of this red arrow, this red one, the sense of this blue one, is it same or different? So if you have confusion in deciding the sense, now what you do, curl the fingers. Maybe I'll tell that thing in class. Can you tell both are in same sense or not? They are in same sense. You will find the blue one is also in anti-clockwise sense. And the blue one is also of same amount 60 degrees. Answer coming same. I hope whatever done on this slide clear to everyone now. I can take a new page. Okay then. Next thing is something called as addition or finding resultant of two or more vectors. Suppose if I add two vectors A and B, sometime I might have to add more than two also. But suppose if I add two vectors A and B, then what I should be writing down on the RHS side. LHS contains vector vector. So what RHS should contain? A is 2 cows, B is 3 cows. 2 plus 3 cows will become not like 6 buffaloes, no? And the left hand side is belonging to some species, the right hand side should belong to same species. So adding A and B to vectors, what we expect answer to be some vector only. Suppose on adding A and B, I got a vector R. How? That we'll see next. So that R will be called as resultant of A and B, first of all. So that will be called as resultant of vector A and B. So on adding two or more vectors, we get some vector only. It means A vector will be bringing some effect, vector will be bringing some effect. Suppose A vector is a force vector, B vector is also a force vector. So whatever job this vector A and B are doing together, same job will be done by this vector R alone. So instead of hiring A and B both, you can hire A and B both, and you can hire one guy R. The outcome will be same. Adding two or more vectors, we get a vector called as resultant vector. So what really it means by adding two or more vectors? Adding two or more vectors means finding a single vector called as resultant vector, which brings same outcome as the vectors that are added when they act together. So I hope you're getting the point. No, A and B are some vectors which are going to be bringing some outcome together. Same outcome R can bring when R acts alone. I can give some simple examples. Suppose if I have a block resting on a surface on which two forces are acted upon him. One is this black one, which is A, and that is of amount n units. And another is this red one B, that is of amount 7 units. So tell me, instead, or maybe I'll take this thing first. So two forces are acting on this object. One is A, which is of 10 units, and another is B, that is of 3 units. Tell me, I want to know what single force I must apply, the one which is going to give us same outcome on the same block as whatever these two are giving us when they act together. So anyone can tell, instead of this two, we must be applying a force that should be equal to how much? 13 units. So if I ask you, tell me how much is the magnitude of the resultant vector? 13 units. And tell me what is the direction of the resultant vector? Same as that of A and B. Because when I apply 13 units, the right word, then only we will be seeing same outcome as whatever outcome I see in this figure. I hope this is clear, no? I will say a vector of length, suppose this direction is eastward. So the resultant of this vector A and B is a vector whose length is 13 and direction is eastward. In this case, I'll say the resultant vector. So whenever I have to report a vector, I must report the magnitude and direction. So I will report it like this. Magnitude is 13 units and direction is eastward. I hope you got the point now. What really it means by adding two or more vectors. How to add, that is different thing. What we get upon adding, that is the thing we must understand first. I hope you understood now, all of you. I can take a new page. Okay, then now we are going to see what is triangle law of vector addition. But maybe I will apply triangle law of vector addition before really telling you what is that law is. So triangle law of vector addition. Using this law, we can add two vectors. And why we add two vectors? To find a single vector called as resultant vector whose outcome is same as that of the vectors which we are adding when they act together. No? Suppose you went for, suppose an object travels, starts traveling from some point O, or maybe some point, suppose P, and it travels some length along eastward direction and then travels some length along northern direction. Suppose he travels kilometers along eastward direction, and the name of that vector is A. So vector A means a vector whose length is 3 kilometers, by which you travel length of 3 kilometers in the direction eastward. And to represent vector A, we are using PQ arrow segment. Maybe this thing you know or not. If I have a right angle triangle having base 3, height 4, then hypotenuse automatically will come 5. So write down the side names like this 3, 4, 5. And these angles are famous angle, you should know, but I'm writing the approximate values of these angles. So in that triangle, this angle will be approximately 53 degrees. This angle will be approximately 37 degrees. Don't use it anywhere other than physics. So from this triangle, if I ask you what will be sine 53, cos 53, tan 53, you can answer. Sine 53, 4 by 5, 3 by 5, 4 by 3. Again, if I ask you find sine 37, 3 by 5, cos 37, 4 by 5, tan 37, 3 by 4. Again, approximate values. But in physics questions, if this angle appear, you will be using these values, even though they are not exact values. So next what happens? First he travels. So that particle is going to do vector A, by which he travels 3 kilometers towards east. Then the same particle does vector B, by which he travels 4 kilometers along north. And to represent vector B, we are going to use the arrow segment QR. So tell me, what single thing I must do to have same outcome? So what is the outcome we are having in here? That particle which was initially at point P will end up reaching the point R. So what single arrow I can use instead of this black and violet arrow, the one which gets the same job done? Is it not going to be this red arrow? Correct, no? So one time you do A and B back to back. Another time you just do PR. What is the outcome you have? That in both the case you will end up reaching R from the starting point P. It means I can say the resultant. So in physics 9th class you must have done finding equivalent resistance. Like you have got like bunch of resistors, maybe in series or parallel, then you find equivalent. What equivalent means, instead of those bunch of resistors given to us in that manner, I will be using one resistor instead. The effect in this circuit will be same. Same way here, it's like sort of finding equivalent only. So instead of doing PQ and QR, what I must do so that the job done same will be PR, no? So I will write the resultant of, or another thing I can even say, sum of vector PQ, that is vector A, and vector QR, that is vector B, is given by PR, no? So if I use the word given by PR, I hope you understand what it means. It means whenever I have to tell about a vector, I have to tell two things: the length and the direction, the magnitude and the direction. So I'm telling the vector PR is going to represent the resultant vector. It means whatever the magnitude of the vector resultant one will be is going to be same as the length of the arrow PR. I'll repeat. Whatever the magnitude of the resultant will be same as the length of the arrow PR. Whatever the direction of this arrow PR is, same will be the direction of the vector A. So see, I'll be reporting the resultant like this. So resultant of A and B so I have to report a vector, so I must be reporting his magnitude. So his magnitude will be equal to length of PR. And to report direction, there can be several ways. One way can be, since I know in what direction vector A is acting along eastward, because they told us to add A and B. So when I am asking you to add A and B, I must tell you, notice that vector A is in what direction he is acting along and all. Correct. So I know vector A is acting in the direction which is eastward. So if I report this angle, that okay, our PR arrow is making this many angle, which we know. How we know? We know that this angle is 53 degrees. So I can use this 53 degrees to tell the direction of PR or not. So I will report the direction like this. It makes an angle phi, that is 53 degrees, from vector A, that is in eastward direction. Now tell me how you will find the length of the arrow PR. That depends on how much mass you know. So we can use Pythagoras to find the length of the PR because PQ and QR are making a right angle triangle, no? So, or maybe if we don't know Pythagoras, maybe we can do it experimentally like that. I will take 1 centimeter is equal to 1 kilometer. And I will draw a line exactly of 3 centimeters to represent vector A, which is PQ segment. Then I will draw an arrow QR of length 4 centimeters. Then I will do a construction of drawing the side PR. Then I will take a ruler or thread to measure the length PR. And I will find the length to be coming equal to 5 centimeters. And we know 1 kilometer is equal to 1 centimeters. So I will know the resultant vector PR will be of length 5 kilometers. However, somehow doing some math will be finding the length of the PR and will doing some math will be finding at what angle PR is from the vector A to report the direction of PR. So whatever we have done is we are applying triangle law without knowing that we are applying triangle law. The next page I'll discuss what is triangle law. But this thing all of you have understood why PR is called as resultant of PQ and QR. So I will write that thing again. So PQ plus QR is bringing same effect as PQ and QR together is bringing same effect as PR brings alone. So resultant of PQ and QR is equal to PR. So PR is going to be the arrow which represents the resultant vector. Okay, I can take a new page. I can take a new page now. Now, next thing is the triangle law. So in order to apply triangle law, which we use it to add two vectors, vectors must be given in some arrangement which we call it as tail head arrangement. So what is that arrangement is if I have to add A and B, so and if I use the blue arrow to represent A, and next I'm going to use this violet arrow to represent B. So where lies the tail of the vector A? Here. Where lies the head of the vector A? Here. Where lies the tail of the vector B? Wherever is the head of the vector A, and this is the head of the vector B. So you see what kind of arrangement they are in, tail, head, tail, head. So wherever the vector A ends, or wherever is the terminating point of vector A, there lies the starting point or tail of the vector B. So in order to apply triangle law, vectors should be given to us in this arrangement. If not given in that arrangement, if not given in tail head arrangement, then we shift one of the vector parallel to itself to bring them in tail head arrangement. Okay, I can take a new page. One more thing I have to tell, some way of telling things in math. Suppose if I give you a triangle Suppose side PQ. This is the side QR and RP. Now you see how I'm writing down these side names. Notice that PQ. So we have a triangle PQR, but how the side names are written now PQ. So PQ ending where? At Q. So the next guy will start from Q. So next side I am writing it as QR. QR ending where? R. At R. So next side starts at R. So RP. So PQ, QR, RP. If I write down like that, then we say vectors are given to us in, or the sides are given to us in same order. So I hope you got the point now. So the sides are like kind of closing onto itself, no? Now if I write down the side names like this, PQ, then QR, not RP, but PR. This is PQ, QR, next one. So see, I'm writing the names here. PQ, PQ ending at Q, next guy QR starting at Q. But the next guy, this one, is not starting at R. Instead, it is like opposite to RP. It is PR. So you see, these two are in same order, we will say, and this one is in opposite to them. So we'll be calling it as opposite order.
One second, sir. Adhe line रहते हैं.
Second, second. All of you got this thing? That what it means by same order and opposite order? Okay, I can take a new page now. I can take a new page. Okay, then now. So I'll write down the statement of the triangle now. Two vectors let's say A and B is given by the sides of a triangle by the sides PQ and QR of a triangle PQR taken in same order then their resultant is given by the third side of the triangle but taken in opposite order. So I'll tell another statement also. So if I have a vector A and B given by the sides PQ and QR of a triangle. You see PQ and QR are taken in same order and they are in what arrangement? Tailhead, tailhead. Then the resultant of this two is given by the third side taken in opposite order. Just when I'll switch to this random man, it's like so noisy here. Just once again, once again. Okay, I hope all of you can hear me. Now, one small thing I will write here. Whenever I write A plus B, so sometimes you don't see them as two things. You see them as one thing. What one thing? The one that you get upon adding A and B. On adding A and B, however we add, we get a vector. So that is what that is A plus B is going to represent. So if I write modulus of A plus B, what it means? I'm talking about the magnitude of the resultant of A and B. Okay. So vector A is given by PQ arrow and vector B is given by QR arrow. So resultant of this two is going to be given by the PR arrow. Another way to state the same thing is if two vectors A and B are given to us in tailhead arrangement, are given in tailhead arrangement, then their resultant is given by the arrow which starts from the tail of vector A and terminates at the head of the vector B. And terminates at the head of second vector. I'll draw that thing again. Same thing it is. So this is our first vector, which is A. And this is our second vector, which is B. So resultant of this 2 is given by the arrow, which is going to start from the tail of the vector A and terminates at the head of the second vector, which is B. So triangle law is just telling me which arrow will be representing the resultant of vector A and B. So like the way earlier, somehow logically we understood that resultant of A and B in this case will be given by this PR arrow. But to find the magnitude of the resultant vector, we do some math thing to find the length of the PR arrow. To report the direction of the resultant, we do some math to figure out this angle. Okay, same way here, triangle law is only going to tell us if you add this vector A and this vector B. The resultant is given by this arrow. So somehow I have to find the length of that arrow to report the length of the resultant, and I have to find in what direction that arrow points to tell the direction of the resultant. I hope this all things done on this screen is clear to everyone. Clear, no? Okay, then now. So this is vector A and this is our vector B. Now triangle law tells us the resultant of this two will be given by this violet arrow. And we are using PQ to represent A and QR to represent B. Now, if I ask you find which is the angle that will be between A and B, so we have done that thing. In this case, I gave you this A and this B. And this one was 120. So to find the angle between A and B, we shifted A parallel to itself and we wrote down A here. So this one was the one that was the angle between A and B. Same way here I'm going to do. So the angle that is between A and B, we understand it's going to be this angle, which I'm calling it as theta. So magnitude of the vector A is same as the length of the segment PQ. Magnitude of the vector B is same as the length of the segment QR. And the magnitude of the resultant of A and B, for which I will use the symbol A plus B, it is same as the length of the segment PR. So some simple math things I have to do to find out whatever the length of the segment PR is. And we know like Pythagoras theorem, so we have to have a right angle triangle. We don't have any. So maybe we will do some symmetrical construction. We'll drop a perpendicular like that. And suppose the foot of the perpendicular, I call it as S. So whenever we come across a right angle triangle, okay, and if this length, this angle given as theta, hypotenuse given as L. So automatically the base we can write down as L cos theta, and the height we are going to write down as L sin theta, correct? Similar thing I will be doing here as well. Check out the triangle, which is QRS. In the triangle QRS, I can write down cos theta to be equal to QS by QR. And what is QR? QR is having same length as the vector B. We get QS by length of the vector B or modulus of B. So from this thing, I can get what is QS is B cos theta. Now same thing I'll be doing using sine theta. Sine theta we can write down as RS divided by QR. So RS will become QR sine theta. QR is modulus of B. So that will be B sine theta. Now our end goal is to find PR segment length somehow. So now we'll check out the triangle PRS. In the triangle PRS, PR square is going to be equal to ES square plus RS square. ES will be PQ plus QS. And what is PQ? PQ is of length same as the magnitude of A. QS we know now, which is modulus of B into cos theta. This whole thing is squared up. And RS will be B sine theta whole square. So if you simplify it, it's going to be C. Who will write modulus of A again and again? Headache, no? I'll write A instead of modulus of A. I'll write B instead of modulus of B. So it's going to be A square plus B square cos square theta. And next I will write B square sine square theta next to him. And one term more to write, that is 2AB cos theta. So this B square cos square theta plus B square sine square theta together will become B square. So we get A square plus B square plus 2AB cos theta. That is modulus of A plus B whole square. So modulus of A plus B means the length of the resultant vector of A and B will be root over A square plus B square plus 2AB cos theta. Now that is not enough. I have to tell the direction of the resultant vector or PR arrow also. So to tell direction, telling this angle, whatever it is, that is enough. And sometimes to report an angle, we can report tan of that angle also, no? So tan phi came 45. So from that we can find how much is the phi. So tan phi came 1. So we can find from that how much is phi. Phi is 45 degrees. So to report the angle, report the direction, I'll be reporting this angle. And to report the angle, I'll be reporting the tan of this angle. So check out this triangle again, bigger one, PRS. What is tan phi from there will be? Tan phi will be RS by PS. And PS is PQ plus QS. So RS will be B sine theta. PQ is modulus of A, which I'm writing it as A only. And QS is P cos theta. So this is going to be our tan phi. So this tan phi is used to report the angle, to report the direction. This is how we report the magnitude. I hope this thing is clear to everyone. I can take a new page. I can take a new page now. Okay, the next thing is parallelogram law of vector addition. So it is not a new kind of law. It is just an extension of triangle law. And when we use it, so every time vectors may not be given to us in tailhead. Maybe if I give you vector A and B, in this arrangement, which is co-initial arrangement. So the violet one is vector A and the blue one is vector B. So what we do, suppose if I ask you to shift the arrow of B parallel to itself. So what I'm going to do, I'm going to draw another arrow of same length as B. just a different location. What location? The one in which I will find him to be in tailhead arrangement with A. So see, this is an arrow, this red one, which is of same length as B, arrow B, and in same direction as arrow B. Just I'm drawing him here. So instead of using the blue arrow to represent B, I can even use the red arrow to represent B, correct? But on doing so, what is the benefit I get? Vector A and this red arrow of B are in the arrangement which is tailhead. But we have shifted B, then A will cry, man, why you're not shifting me? So I will shift A also. I'll shift A parallel to itself, and I will draw him here using this black arrow. So this black arrow is of same length as this violet arrow and in the same direction as the violet arrow. So even I can use this black arrow to represent A. Now on doing this shifting things, we ended up forming a parallelogram. Correct? Maybe I'll name that parallelogram as EQRS. Now do one thing, concentrate on this violet arrow and red arrow only. Forget about everything else, whatever drawn. Just you think, just have a narrow vision, no? Where you see only this violet arrow and this red arrow only. And you check what kind of arrangement they are in, tailhead. So what is the resultant of this two will be? It's going to be given by this yellow not visible, no? So resultant of the vector PQ, the violet one, and the vector BQ or the red one will be given by this pink arrow or not. So from triangle law only what we are telling is on adding PQ and QR. See, one more thing you can do also. Maybe I'll write here also as well. So suppose if you are not drawing the figure, maybe I am writing down them like this. Suppose here arrow of A is PQ and arrow P is what? QR. So if I write down PQ, then which is the tail of PQ? P, and which is the head of PQ? Q. Which is the tail of QR? Q. Which is the head of QR? R, no? So you see what kind of arrangement they are in, tailhead. And maybe you can see one more pattern here. The PQ and QR has Q sandwiched between them, no? Correct? Q is like sandwiched between P and R. So one Q kills other Q, it becomes PR. Or you can do it like this, take the tail of first guy and the head of the second one, and you make a new thing out of that PR. That will be the resultant of EQ and QR. I hope you got the pattern, no? Like take the tail of doggy, take the head of tiger, you got doggy tiger, new kind of species. Take the tail of PQ, head of QR, you get PR. That is the resultant of PQ and QR. Same way here, PQ, even I don't draw the figure, not the issue at all. PQ plus QR is going to be what? PR, no? And what is PQ really also is vector A and QR is also vector B. So A plus B is given by PR. Now this PR guy is two things simultaneously. Like same person can be brother also, can be father also. Correct? Like person is same way. This PR is the third side of triangle PQR. And is it not correct to say it is also the diagonal of the parallelogram PQRS? Hence name came parallelogram law of vector addition. So I hope this is clear now. How we are finding resultant using triangle law only, which is telling me that PR is the resultant, but PR is also the diagonal of the parallelogram that we frame by shifting vectors A and B parallel to itself. So everything will be same, formulas and everything will be same. So if you check out this violet arrow of A and blue arrow of B, they are in co-initial arrangement. So this is the angle between them, the vector A and B. And that theta, is it not same as this theta? Both are same only, you're not? So after that, everything same, you draw a perpendicular and everything will be same only. So length of the vector A plus B, same formula. The angle made by the resultant vector with the first vector, that is something we call it as phi. That tan phi formula also same, nothing different at all. So how the statement goes like this is vectors A and B given by the sides PQ and PS. And what kind of arrangement these sides are in? These vectors are in co-initial given by the side PQ and PS of the parallelogram. Parallel GM means parallelogram. PQRS. Then their resultant is given by the diagonal. So, moment I say diagonal, things can be confusing. It could be SQ, it could be QS, it could be PR, it could be RP. So four ways I can draw the diagonal, no? So PR diagonal can be drawn two ways, RP and PR. SQ diagonal can be drawn two ways, SQ and QS. Which one? The one which is PR, and how that PR is. The tail of PR, the tail of B, this blue arrow B, and tail of violet arrow of A are at same location or not. So it is given by the diagonal PR. See which vectors really, which arrows I'm adding PQ and PS. So PQ starts with which letter? P. PS starts with which letter? P. And resultant vector starts with which letter? PA. Correct, no? So it's given by the diagonal, which is in co-initial arrangement with PQ and PS. I hope this parallelogram law vector addition clear to all of you know. Clear, no? So I've shared a link in our group. So you check out the last 20 minutes of the vector backup class 2. Okay. And tomorrow again we are going to have backup class for vectors. Once vectors gets over, I'll start calculus. And what timing is okay for you? 7 to 7 p.m. onwards, okay, no? 7 p.m. onwards, okay to everyone, no? 7 p.m. Tomorrow I'm on leave, but maybe on my own time I'm doing the backup class. So 7 is okay, no? Same thing I've thought once more, man. And like so many times, I don't know. So vector backup one, and so many one happened. Date is 27 July, weekend phase 3. So I'll share this thing in our group, and maybe by tomorrow or by night, I will share the recorded session also. And in the same channel, you will find vector backup one. That is not something you're supposed to see. That is done now. Vector backup two, you see the last half an hour or 20 minutes, so that we can save some time tomorrow. Okay, then bye everyone. See you tomorrow at 7 p.m. I'll post in the group also regarding that. Okay, I've shared that PDF in the group. Check out. Bye everyone. I'll end the class.